The distance formula can be used to help you find the distance between 2 points on a coordinate plane, or if you know the coordinates of the 2 points that aren't actually graphed onto a coordinate plane. So there's a couple of ways we can look at this. I've got some examples graphed here. We have point A here, which is at 6, 2. We have point B, which is at 6, 4. I can tell looking at these two that the distance here is 2 units because there's 1, 2 spaces between the two. For CD, C is at 1, -4, and D is at 7, -4. So the distance between these is 1, 2, 3, 4, 5, 6. So the distance here between these is 6 units. Now where this whole counting strategy doesn't work is when you have something like between EF. E is at 1, 1 and F is at 5, 7. It's really hard to sit here and count how many steps it takes. I mean, we can get an estimate, but we don't know exactly the exact distance between the 2 points. So what I want to point out is that we can do something here where if we're looking between A and B, the x's do not change, but if you look at your y's, this y, A is at 2 and B is at 4. Well, 4 minus 2 is 2. If you look down here at CD, your y's do not change because it's a horizontal line, but your x's, C is at 1 and D is at 7. 7 minus 1 is 6. So that's one way you can look at the coordinates to help you determine the distance. Now the problem is when you have a point, again, when you have it like this, the distance here between the x's is 4 and the distance between the y's is 6. So I can't say that the distance is 4, 6 or 6, 4. I can't do anything like that. So we're going to have to use what we talked about, the Pythagorean theorem. So here this is again, I got rid of the other examples just so we can focus on this one. And what the Pythagorean theorem, if you look at this, if I draw a line down to here, and I draw a line over to here, okay, the distance here is 1, 2, 3, 4, 4 units, and the distance up is 1, 2, 3, 4, 5, 6 units. This now makes a right triangle, and we can use the Pythagorean theorem to help us find the length of this, which would be the hypotenuse of this triangle. A squared plus B squared equals C squared, and this unknown distance between these 2 points would be represented by C. The reason I want to point this out too is if you look, notice that the changes in my x's are 4. That's how far over I'm going on the x-axis. And then if you look at the y's, the changes in my y's are equal to 6. That's how far I'm going up on the y-axis. And it's going to make more sense in a second why I'm pointing that out. But just looking at the Pythagorean theorem, we'll call this our A, so 4 squared. We'll call this our B, so that's going to be 6 squared. And I apologize, the writing is horrible when I record. So A squared plus B squared equals C squared. We don't know what C is, so we're going to leave that as C squared. So 4 squared is equal to 16. 6 squared is equal to 36, and this is equal to C squared. 16 plus 36 is 52, and again, that's equal to C squared. So that means the square root of 52 is equal to C. Now, I would like for you to give your answer, unless I say otherwise, as a simplified radical. So remember, we simplify radicals. We say, well, 52, we find the prime factorization. That's equal to 2 times 26. And 26 is equal to 2 times 13. So that means that the square root of 52 is 2 square root of 13, and that's equal to C. Remember, we pull out our married couples, and we're left with 2 on the outside. So 2 square root of 13 is the distance of C. That's the exact answer, and you would not have been able to estimate something like that, okay? Now, what I'm going to show you is the actual formula that you can use to help you always calculate the distance between 2 points. That way it'll keep you from having to draw triangles every single time, and you're not always going to have it on a coordinate plane. Sometimes you're just going to be given the points. And so here is the distance formula. And it looks like it's really, really complicated because of these subscripts here with the ones and the twos, but really the reason is because you have, when you're looking at a point, you have two x's, or if you're looking at a pair of points, I'm sorry, you have two x's and you have two y's. If I gave you 2 comma 3 and I gave you 4 comma 7, notice you've got two x's here, right, x1, x2, and then you've also got two y's. So that's why those subscripts are there. It doesn't really matter which one is 1 and which one is 2, but you need to stay consistent. If this is going to be x1, then this needs to be y1. And so then if this is x2, this needs to be y2. But it could be vice versa. This could be x2 and y2, and this can be x1 and y1. It just needs to be consistent. Okay? And so then you would just plug this into the formula here. And so, just to change colors, so I'm going to replace this with the x1. I'm going to replace this with the y1. And I know this is confusing with all these lines. I'm going to place the x2 there, and then the y2 goes right here. So let me show you what that's going to look like all plugged in. Okay, so we said x2 is 4 minus x1, which is 2. And all of that, we're going to take that difference and square it, and add that to our y2, which is 7, minus our y1, which is 3, and then we square that. But we're going to take the square root of all of that. And the reason is because if you come back up here and you look, this is a squared plus b squared equals c squared. So can't you say here that this was our a, here is our b, the difference, and so c is equal to the square root of all of that added together, those differences added together. That's what you're doing here. You're finding the square root of the differences and you're adding them together. So that's how the distance formula came about, or where it comes from. So now I'm going to go through and simplify this. 4 minus 2 is 2, so I've got 2 squared. 7 minus 3 is 4, so I've got 4 squared. And I'm taking the square root of all of that. 4 squared is 4. 2 squared is 4. 4 squared is 16. So this is going to be the square root of 20, which remember, I want this written as a simplified radical. 20 is equal to 2 times 2 times 5. So when I pull out that married pair, square root of 20 is equal to 2 square root of 5. And then whatever the unit is what the units would be. So this 2 square root of 5 is the distance between these 2 points right here. Okay? So let me show you. Here it is. Let's say we have this point and this point right here. Okay? And I want to find the distance between these 2 points. Well, again, I can make it so it's like a right triangle, and I can do all that kind of stuff. Or I can look at it and say, okay, well, this is at 2 comma 1, and this is at negative 1, 2, 3 comma 4. So this is negative 3, and that looks awful, sorry, comma 4. Okay. So you want to point out, you don't have to necessarily write it every single time, but I'm going to make this my x1 and this is my y1, and I'm going to make this my x2 and this is my y2. Again, just so that I'm consistent here. So I'm going to plug everything in, and I've got my x2 is 2 minus my x1, which is negative 3. And we're going to take the difference between those and square it, plus my y2, which is 1, minus my y1, which is 4, and I'm going to square that. Running out of room. Alright, so 2 minus negative 3 is 5. 5 squared is 25. 1 minus 4 is negative 3. Negative 3 squared is 9. So this is going to be the square root of 34, which cannot be simplified. So this is it. This is your answer. Whatever the unit is, you would just say units. This is the distance between these 2 points here is the square root of 34, and then whatever the units is. All right. So then let me give you another one. Again, sometimes just the points are going to be given, so this is where the distance formula comes in handy. I'm going to call this x1, y1, and then I'll call this one x2 and y2. And I'm going to go ahead and plug everything in here. So it's going to be the square root of x2, which is 7, minus x1, which is 3, and we're going to square it, plus y2, which is 12, minus y1, which is 4, and then we're going to square that. 7 minus 3 is 4. 4 squared is 16. 12 minus 4 is 8. 8 squared is 64. So when I add these two together, I get the square root of 80. That looks awful. Which is equal to the square root of 2 times 2 times 2 is 2 times 5. So again, I'm going to go through here, pull out my married couples, and I end up with 4 square root of 5. So whatever the unit is, 4 square root of 5 units is the distance between those 2 points.